Hello everyone. I am Dr. V.V. Kamesh, Professor of Mechanical Engineering, Aditya Engineering College, Sorampalam. In today's class, we will discuss about Babcock and Wilcox boiler and its working principle. So coming to the different types of boilers, like fire tube boilers and the water tube boilers. In this, we will discuss about water tube boiler. So Babcock and Wilcox. So the learning outcome about this lecture is, at the end of this lecture, the student will be able to explain the working principle of Babcock and Wilcox boiler. So this is the line diagram of Babcock and Wilcox diagram, Wilcox boiler. And this is the model which is present in our laboratory. Okay, coming to the fundamental parts. So first one is the boiler shell. So we already discussed about the classification of the boilers with the axis of the shell or the cylinder, horizontal, vertical, or inclined, right? So here the cylinder or the boiler shell will be horizontal, right? Now you can see here, initially we'll have the water is filled with more than some half, right? So in the left it is attached water level indicator, and to make the water to enter here, feed check valve, and to get the pressure of the steam inside after production, will fix pressure gauge and safety valve, anti-priming pipe, stop valve, drum, and okay. We'll discuss about the superheater tubes later, baffle plates. These are exclusively for Babcock and Wilcox only. So other boiler mountings and accessories will be common to all boilers, but there are some few devices or some adjustments which are only exclusively for a particular boiler, right? So different parts you are able to see here: uptake header, downtake header, baffle plates, and water tubes. Water tubes is an integral part, and you are seeing some directional arrows, right? So there is a curve. So what is this curve? What we'll have? So we'll discuss one by one. Now you can see part by part I will explain. So you are seeing the blue color, this is water, right? So this is the steam drum or drum, simply you can call it as. And you are looking two angular tubes. So short tube and long tube. Why we are making the different lengths? We need to create an angle of 15 degrees, right? So why the angle is to be given, we'll discuss. So uptake header and downtake header. Downtake header means it will go down, right? Creating some angle. Actually, even though you are calling this as header, these are all water tubes, right? So water is coming, you look at the right extreme, from this passage, water will come through longer tube and come to the down header, and because you are having some linkages with the water tubes in between, so water will pass on in this area, and again it is going to short tube, right? So once the water is given opening, automatically entire water will fill the longer tube, down header, water tubes, and uptake header and short tube. So entire area will be filled with water, right? Now, so this is the angle which I told earlier. Okay. Now you can see. Right. So in addition to this steel drum, uptake header and downtake header with some angle, we will fix baffles, right? We will fix baffles. Baffle means simply the directional obstacles, right? So to whom we are creating directional obstacles, right? So we discussed about the working principle of the water tubes. So water is inside the tube now. Now the water tubes are to be surrounded by flue gases, right? Now, where we will get the flue gases after burning the fuel? So, you look at the downstream, there is a fire door, there is a coal, and there is a grate, right? So, on the grate, we will place the fuel and we will burn it, and automatically there is a generation of hot gases, right? Now, we are having a small problem here. If the baffle plates are not arranged, what will happen? Whatever the hot gases that are produced in the fire area, they are going to heat only some portion of water tubes. But to get the higher thermal efficiency, all all the volume of your water tubes are to be heated. So we need to pass the hot gases to pass through all the surrounding surface of the water tubes. So what we need to do? So directional baffles are to be arranged here. So once the uptake header part is heated, now the gases will go down and again go up, and finally they will go to chimney through a damper arrangement at the bottom. You can see bottom right, there is a damper. So after heating all the locations of the water tube, right? So finally the hot gases, after reducing their heat, they will go to chimney. Okay, right? Now we are having a small item that is in between superheater, right? So what is superheater? We know about economizer or air preheater. This superheater means whatever the steam that is produced inside, it is again circulated through hot gases area, so that some of the hot gases heat that will be transferred to the steam, and the steam will get superheated. So the steam at 100 degrees centigrade may be increased to steam at 120 degrees centigrade, or at least 10 degrees centigrade rise, right? So superheating means heating already heated object. So already the steam is at 100 degrees centigrade, heat more, right? So you are looking in the diagram, steel drum, pressure gauge, water level indicator, steam stop valve, and safety valve, uptake header, downtake header, baffles, right, and fire and damper, right? Now you can see the working principle, what will happen after the fire is started. After the fire is started, the water is gets heated in this area, right? Already we located how the hot gases will flow, right? Okay, that is regarding the gas flow. What about the water flow? Water is already filled in the uptake header and downtake header, right? Now, how the steam will be generated and how the flow of water and steam will be in the boiler. Now you can see in the fire area, the water will get heated and steam will pass through uptake header to the drum, right? So drum is half filled and the remaining area is empty. In the empty area, steam will be accumulated. Okay, right. Now, as the water gets heated in the uptake header part and going to the transformation as the steam, so here some space will be created and the density of water here will be less. So automatically it will get up, right? Now this place will be filled with water from the down header. So automatically water will get filled in the uptake header, converted into steam. It will go to drum. Again, the water from the drum remaining area that will come to the down header, and due to the density difference, the water will go up, and automatically this will be circulated until you are getting steam completely at your required area and the required quality. Okay. Now this is the way how you are having the gas flow and water flow. Right. Now you can see in this diagram, we are having another item that is mud box. So already you know water will have some impurities, and after heating, there may be some formation of the scales due to some impurities and dissolved salts. So there we need to have some mud box, right? So as a periodic maintenance, we need to open the mud box and let it go out. Okay. Right. So in boiler drum, we are seeing water space and steam space, right? So water is in the blue color and steam is in some with bubbles, you can see. Now in the bottom, the mud box is there and the items will be drained by Babcock. Now you can see here, superheater. I told you earlier, superheater we are using to increase the heat of the steam already collected in drum. Okay. So the steam drum, whatever you are having the steam, there is a superheater. So steam will pass through the superheater and it will be circulated through the pipes which are located in hot gases area. So the hot gases while transforming from uptake header to the downtake header, in between they are visiting the superheater tubes. So automatically some heat transfer will be there. So due to that heat transfer, steam will get superheated. Okay, right. So this is the working principle of Babcock and Wilcox boiler, and the advantages and some characteristic features we'll discuss here. This boiler produces steam up to 2000 to 40,000 kgs per hour. Okay, so maximum capacity is 40,000 kg per hour, and it takes less space as compared to other boilers. So here the less space means for a particular generation of the steam target, it will occupy less space. And boiler tubes can be easily replaced. So here the either it may be water tubes, right? And it is the only boiler that is used to produce a huge quantity of heat in the power plants. And in this boiler, the drought loss is very less, and it can be easily repaired and cleaned, and we are having high overall efficiency. And obviously there will be some limitations or disadvantages. So the large maintenance cost is one of the difficulty, and it is not suitable for impure and sedimentary water. So in discussion of your mud box and the blow of cock, I told you when there are impurities in the water, definitely there will be a scale formation, right? So the scales will accumulate in the tubes and this causes the tubes to overheat and burst, and water treatment is necessary before feeding into the boiler. So there need to be some separate plant, feed water treatment plant. So the water to be entered into the steel drum or steam drum, whatever it might be, right? It should be very pure, right? And a continuous feed water supply is needed to work. If continuous water is not supplied, even for a small duration of time, in this case, the boiler is overheated and water level must be strictly observed during the process of Babcock and Wilcox boilers. And to the end of the lecture, the students have learned the characteristic features of the Babcock and Wilcox boiler and working principle of Babcock and Wilcox boiler and advantages and limitations. Thank you very much. If you like the video, please like, share, and subscribe. Thank you very much.